All right. Yep, it looks like it's working. Okay. Gotta minimize a few screens here. Lots of screens. This is where I was, by the way. This is one of the places that we flew with a drone. So we didn't plan to do much drone flying, but this was on the Cayman Islands, and this hotel right here, or right back here, well, part of a hotel. They want to actually expand, and they want to get rid of all of this beach rock. This is so when you walk out on the beach, it's sandy until you get to here. This is like rock, and you can tell that it's broken up past here. And they just want to come in with a bulldozer, even though it's under about 10 inches to a foot of water. And they want to just get rid of all of that to, in order to make it, nice for the beachgoers to have a sandy bottom. And so the Department of the Environment wanted us to collect, just like spontaneously. We're actually down there showing them a web app. But they said, hey, can you all go collect the data here? And so we did. It's pretty cool. We've got, let's see, I made a little video of a fly-through output. So that's the area. This is the beach rock that they want removed, and you can actually see the 3D of the rocks. You can see the fact that those are individual rocks. You could measure them. You can do whatever you want. There is some error right here in the surf zone. You can see these like anomalies that happen right there as the land-water interface meets. There's a big one right. Some big ones right there. Other than that, it did a pretty good job. And so I was down there presenting at a conference, presenting a web app, and then we were also testing this thing for mapping the reefs themselves. Sure. I don't know if that video goes through the system. Does it? Does it go through the system, Elida? It worked? Okay, cool. All right. It's really dark now that the time's changed with the lights off. Kinda. Right. It's hard to see the screen without it. I understand. Okay. So today, this week, what we're going to do is we're going to look at Blackboard and got too many windows open. Tomorrow tomorrow at 8 o'clock I have to be in Tallahassee. So after this class, I'm driving over to Tallahassee, and I have to talk for a whole hour. I've only done that in class before. I've never done a presentation for a whole hour. I'm a little nervous. Well, I think it's a conference. I think it is on the campus of Florida State. It's their like GIS conference. It sounds like it's about the same size as what do you call it? Mast. Maybe a little bit larger than Mast. But yeah, I'm given what they call the keynote. Basically, were you here when Jamie Hughes was here? Okay, so Jamie Hughes was a student. She's an undergrad, but she's over there working, and so she's on the committee for this conference. So she broke David Holt into doing it last year, and so now I guess it's my turn. Yeah, the Shrug Conference. It's a funny name. All right. Okay, so today we've been doing a lot of web mapping up to this point, but but we haven't done a lot of web GIS yet. I mean, you could call what we do GIS because mapping falls into that category of GIS, but we're going to actually do some GIS operations, like on the fly, for the next 2 weeks. That's what we're going to do to finish off the course. So today we're going to talk about doing GIS operations right on the web in JavaScript on the client. And next week we'll talk about creating GIS services. So the difference there is that the JavaScript executes the GIS operation in the browser this week, and next week the information that's needed is passed to the client. Passed to the server. The server does the GIS operation and then passes the result back. Now, advantages and disadvantages of both of those approaches. Doing the GIS operation, first of all, before I get into that, what do I mean when I talk about GIS operation? What am I talking about there? Yeah. I'm just going to Google GIS operations and see if something good comes up. Oh, that's a bunch of text. That's no good. What are some GIS operations that you've used before? Maybe that's a better way to say it. Give me some examples. A lot more text there. The spatial analysis. That's still. That's good. Give me a specific example of something that you might do. In ArcGIS, these are oftentimes implemented in the toolbox. So like, what's that? An image classification? Sure. Yeah, that's a good example. Clipping. Yeah, clipping would be good. Clipping would be an example. Let's see if I just type in clip here. We all know what clip does, but see if there's a good summary of that. So if we have an input, we have a feature that we can clip it by and we get an output. Cool. Yep. A buffer. I think I heard somebody say that. Buffer is a GIS operation where we have an input and we buffer that layer. Here's our different inputs, points, lines, and polygon inputs. We buffer the layer, and the result is usually a polygon when we buffer a layer, and we get an output that represents the entire area that is within a certain distance of that object. So everybody here's probably used these sorts of things to different degrees. You may not be an expert on GIS operations, but you've probably done them in a GIS course or are doing them presently in a GIS course. That's one of the prerequisites for this course. Does that sound right? Okay. All right. So that's what we're talking about today. So back to what I was getting at before. The advantages and disadvantages to doing the operations on the client versus the server. When you actually like today, when you actually go to execute a buffer or a clip, which are both things that we'll cover today, on the client, you're dependent on the speed of the machine that the client is. In other words, the person sitting at their desktop, when they go to do a buffer, they go to do a clip, the code is executing on their computer. So that's what happens in JavaScript. I tried to explain that before in several other classes, but the code actually is what's passed through the internet. So the code is on the server, but the code gets passed on the internet, and the code actually runs on the client. So today, when we do these operations, that's one of the characteristics of doing a GIS operation on the client in JavaScript, is that it's dependent on the speed and the processing power of that computer. So that's can be a disadvantage or an advantage depending on the speed and processing power. Generally, JavaScript, this is another point, JavaScript is was not designed, not optimized for doing large computations. So if you have a lot of data to generate when you do your buffer or your intersect or your clip or whatever you're doing, if you have a lot of data, it will perform slower on the client. But the trade-off is, if you have a lot of data, it will also take a lot of time to send that data to the client in order to be processed. Okay? Now, sometimes we can get around that. If we're serving up a dynamic map service, what the user is actually seeing is what? For a dynamic map service, what does the user actually see? Do they actually see points, lines, and polygons, or are they getting an image? A dynamic, what's that? The dynamic map service, they're actually, well, no, they're receiving an image back every time. Every time they pan and zoom, they get a new image. And so if the data is already on the server, you don't have to make that exchange. In other words, you can just say, okay, let's do a buffer of this feature. It's already on the server. And so we'll cover that next week. Do buffer this feature, it'll buffer, create a new feature. But if that data exists on the client, then, or it already exists on the client, it might be faster to do it on the client. So you just have to keep all those factors in mind because they are kind of like a moving target. You have to consider where is the data and how quickly can we get this particular operation to work on the client or on the server, and which one will be more tolerable for the users. In any case, oftentimes doing GIS operations in a web environment does take a little bit longer than it would on a desktop environment. There's really not much way to get around that. But if you have a few points and they're already on the client, it's a few features and they're already on the client, it's oftentimes better to do a client-side GIS operation, which is what we'll cover today. If you have a lot of data and it's already on the server, oftentimes it's better to do the operation on the server as a web service. So those are the summary. Those are considerations. All right. So there are a few libraries for doing this, but we're going to talk about the turf.js library today. And in order to start on this conversation, I'm going to download this LL example week 11.html. And that's what I'll be working off of. Should I go ahead and make the text a little bit bigger? It's okay? For now, it's all right. I'm going to download this. Right click. I'll save this as week 11 here. And then I'll open this up in Notepad. All right, good. Now this was just, I modified this a little bit from weeks past. But one thing that I did was I actually downgraded this back to version 2. Version 3 of Turf isn't as complete yet. They're developing. They've already released it, but it actually has less available functions. And so you'll notice that in some of my earlier labs, I had this in here just because I knew we were eventually going to be utilizing Turf. But I was using version 3, and this lab is using version 2. And, that's just because version 2 is a little, like I said, a little more complete in terms of the functionality. I also have to download statedata.js. If I don't download it, this example won't work. So I need to download that and put it in the same directory, which is just, where did I put that other one? Looks like I put it, Looks like it's in downloads, so go ahead and save it in the same location. There it is. All right, so now when I go ahead and open this leaflet example 11 in Chrome, then I'll see the result. I'll just let you know really quickly what it's doing. The first thing that it's doing is actually reading in all that earthquake data that we were running before, and this may look very similar to the earthquake lab where I tried to make high large earthquakes red, medium earthquakes orange, and smaller earthquakes yellow. Okay, remember that was the end result of one of the labs. The difference here is that I actually am using turf.js to classify these for me. So turf does that. I put a link to turf here. Okay, so the version 2 help for turf is just a bunch of examples, which I think examples are cool. So here is the example list. So here's all the functions that turf does, and or at least turf version 2 did. And you can click any of these operations, and it'll give you an example. For example, here's buffer. So this turf.buffer does a buffer. Turf.filter. This is the one that I was actually thinking of when Heather came up to me today. So turf.filter will actually run through and do a filter based on a parameter. Here, this is the description. Keeps any feature from a feature collection that match a property value. So you could say, okay, if they type in red, then you could run turf.filter and find all the operations that said red, and it would just keep those. So you could write the code so what it did was create another layer, and then show that layer and hide the entire layer, and then if you wanted them to go back, you could have them press another button that would reveal the initial layer. But like I said, you would have to write in all you have to write more code probably to get that to work. There are also kind of like just data generation functions. There's a function to create a evenly spaced grid. There's a function to create a series of hexagons over an area. And we'll try to do we'll try going through some of these today. So there's a union, which is GIS operation. This one basically combines two polygons into a single polygon. I don't know how that's different than a combine. Okay, just combines. These combine them into one feature collection. Combine combines them, or union actually merges two. So there aren't a whole lot of functions here, but there's enough to do a lot of different spatial operations. So let's look at my example that I came up with. So this is all the same as, in fact, this is just I should delete that. I mean, that's just a line to make sure that turf was working. I put that in there as I was debugging. So there's really no reason for that. And the rest of this code is just code that creates the base map and adds that base map to the layer. All right. This code should look familiar. This is the code that gets the GeoJSON for the earthquakes. Okay? But instead of manually deciding where the breaks for high, medium, and low are, what I did was I ran this function called turf quantiles. And by the way, before I get too far, the way almost all of these functions work is that you use the function, you pass it some features, some GeoJSON features, and maybe some other parameters, and the result that comes back are new GeoJSON features. So breaks are either new GeoJSON features, or in this case, they're actually the breaks. Let's look at the help for a quantile. So turf quantile here. Okay. What it does is it takes a set of features, a property name, and a set of percentiles, and outputs a quantile array. This can be passed as a breaks array to the isolines function or the isobands function, or you can use it for something else, which is what I did. Okay, so let's just take it to this point. So this console.breaks is going to show up. It's going to appear in the console log. And maybe that'll help you get a better idea of what it's doing. So what I'm going to do is go to Developer Tools. I'm going to run that. And so this is that first console log that just has the earthquakes in it. This is the second console log, 3.1, 4.6, 7.8. Okay. Why did it produce that? Well, I'll explain that here in a second. I'll explain that right now. Okay. So if we go back here, it's running this quantile function. It's feeding in the quakes, and then this mag is actually one of the attributes, and then these are the quantile breaks. So if we go back over to the help real quick. Scroll down here. Here's the example. So it's saying, okay, here's the GeoJSON that you're feeding it. This is the name of a field. Wish it was better documented, but that's what that is. That's the name of an attribute. And then this is the percentiles. This right here is this right here. Okay, what's a percentile, by the way? Like if somebody said that that's exactly what it is. All right. There's a fancy word for the 50th percentile. What is it? Anybody that remembers from statistics class or a statistics class, statistics lesson? What's that? No, that's a good guess though. The 50th percentile means half the values are below and half the values are above, right? If 35th percentile, you're better than 35%, which means 65% are better than you. Okay. Everybody remember what that term is for having half the values above and half the values below? It's not mean. Mean just means the average value. Exactly. It's the median. The median is half the values above and half the values below. So if we just put in 50, we would get a single value. In fact, I'll do that right here. I don't know if it'll cause an error later in my code, but I'm going to just put in 50 and then refresh this page. And the number that appears here should be the median value for all earthquakes, 4.2. It didn't cause an error. So that's the median value for all earthquakes. So when I change this back to 33, 67, and 100, what I'm doing there is I'm doing thirds. In other words, I'm saying the bottom third, the middle third, and the top third values. Does that make sense? Because 100 means all the values are below at that point, right? So that's what I'm generating are those lines in the sand. I'm figuring out when I run this again I guess I didn't save it. When I run this again, these values 3.1, 4.6, and 7.8, what those mean is that for this particular time period, these are the earthquakes within the last week, it looks like, back up here. Okay. What it means is for this particular time period, there were a third of the earthquakes were below 3.1, a third of the earthquakes were between 3.1 and 4.6, And then the final third of the earthquakes were between 4.6 and 7.8. Exactly. That's all the earthquakes on the map. That's for all the earthquakes that were loaded. Okay. It's a good point. So you could probably see the advantage to this is that, remember when we did this in class and we made the assignment, I told you to just find some good values. Well, the problem is that earthquakes continue to happen, and those values may not always be the appropriate values. It may be with an earthquake you always want to use the same cutoffs, but there may be other things where you actually want to have the data have kind of an even distribution. You want to be able to see everything. And if it changes, this might be a cool function for you to be able to use. And in fact, that's what I did with this function. So if we go down here, well, actually I ran it, I can't, no, breaks. Yes, breaks. So I just used the same sort of function for symbolizing the data that we did before, except for I said, okay, if the property features.property.mags is greater than the first break, make it large. If it's greater than well, actually that would be the second break. Greater than the first break, make it medium. I didn't spell medium right, but I must have not spelled it right up here too. Yep. At least I was consistent in my misspelling, so that's why it works, because it's just a variable name. And then finally, if anything else, it's just small. So I'm really only using those first two breaks. I don't really need to know what the highest break is, because basically, if it's bigger than anything, it's in that one, or smaller than anything, I guess is what I'll say. All right. So that's what I did there. I probably should have just ended my example at that point. But what I did was, and then we could have done the rest of this together. But the next thing here, what I did was I used this average function to come up with the average value of the quakes by state. So let's look at that in the example. That's right here. It's under average. We read what it says. It calculates the average value of a field for points within a set of polygons. In other words, if you have two polygons, these are two polygons, and you use this function, it'll find the average value for a field within that polygon. How would we do that in a GI, like in ArcGIS? What would be the equivalent tool if we wanted to do that sort of thing? Let's say we had a bunch of points, and the points represented, let's just say they represented, we were going out, we were collecting data, and they represented some measure of pollution. And we wanted to find, they were like points in cities, and they represented some measure of pollution, and we had all the states of the United States, and we wanted to find out what the average amount of pollution there was in each of those points that represented cities for each state. How would we do that in ArcGIS? What's that? Zonal statistics would work if the data was raster. Yeah, that's true. And we could just convert it to raster in order to do it. So we could convert all of the states to a raster data set and the points to a raster data set and do zonal statistics. And that's exactly the way we would do it in raster. It's a great answer. Okay, but what if we wanted to leave the data in vector? There's a tool. Have you, in any of your classes, did you run spatial join before? Spatial join? Okay. What's that? Yes or no? Yeah, okay. So spatial join would do the same thing. So this is basically doing a spatial join and calculating an average while it does that spatial join. Okay. There's a buddy function that does the sum. So that might actually be better for the pollution. So we could find out the total pollution in a particular state. might be better than the average, because the average would probably pull one down and the other down. But so the sum is a buddy function for doing that. So this function here basically requires, so you can look at this example. Again, it would be better if there was actually text to help you determine which to use. But if you can look at this example, you can see that the polygon feature class is the first one into the function. I'm on sub, but it's the same with average. The polygon function is the first one into the function, and then your points, and then you have to give it the field that you want summarized, and then you need to give it the description. What is the description? Okay. The description is basically just the name of the new field that your joined features, your polygon features, will get. So your polygon features will get a new attribute. So, and that will be assigned to this new value. In fact, I'm going to console.log that right now so we can see what that value looks like. Console.log averaged. And in order to show the difference, before that's done, I'll console.log state data. So we're going to log both the state data and the average data and see what happens. All right, so I'm going to rerun this. So it's these two lines, because we logged, first we logged all of the quakes, then we logged the breaks, and now we're logging the features. So this is just the states data before the operation. And you can see that we have some features, and if we look under properties, we have that new mag average. Now this mag average is for Arizona, and it says NAN. Why do you suppose it does that? What do you suppose? What do you think NAN means? Yeah, in JavaScript, NAN stands for not a number, but that's what it's telling us. It's no data available. Why doesn't Arizona have a value? Right. So we're trying to calculate the average magnitude of all the earthquakes in Arizona, and we wind up with NAN, not a number, okay, because there are no earthquakes in Arizona. Not exactly sure why Idaho, maybe Idaho has, anyway, we'll have to look at why that happens. But so what's the first state? California. So California might be maybe number 5 alphabetically. District of Columbia. Nope, maybe it's number 4. Properties, state of Connecticut. So California's, I didn't realize there are so few A states. Arizona, Arkansas. I guess that's it. Arizona and Arkansas. Okay, so California is the 3rd state alphabetically, and we could see that its magnitude average is 2.874. In other words, the average magnitude of all the earthquakes over the last week in California was 2.874. That's what that's saying. Okay, because it calculated that value there. Oh, and if we look at it before, it won't have that value. Oh, magnitude average is there. I guess it assigns it into the data itself. It's not really a problem. I didn't realize it did that. So it assigns it to state data, and it assigns it to the output. They don't all work like that, but this one evidently does. So I looked at both console.logs, and they each have this new attribute called mag average that resulted from this function running. It's basically performing a spatial join, and you could do it with any points and polygons. So one thing that you could do is that although we didn't cover it in this class, you could let the user draw a polygon, and then you could calculate what the average value for any of your values was and return that to the user and say, here's the average value in the polygon you just drew. Something like that. Okay. If you wanted to draw a polygon, there is an example of how to do that in Leaflet, or you could ask me and I could provide you with an example of how to do that. Okay, I'm going to go ahead and delete these console.logs at this point because they're just doing that. By the way, this is a comment to help you know what we're doing, calculating the average magnitude by state. Okay. This next line, it tags the quake data set with the state data set. In other words, it's kind of like an intersect. I'll show you here. Perf.tag. Turf.tag. Performs a spatial join on a set of points from a set of polygons. It's like the opposite of what we just talked about. It doesn't aggregate the points. It basically says, okay, take the values, all you points, take the values of the polygons underneath them. So here's the example down here. It's going to take the point feature class and the polygon feature class. Notice that the point feature class is first. It's consistent in the first data set that's being fed is the data set that's going to receive the values. So the point feature class is going to receive the values from the polygon feature class, and this is the attribute that it's going to receive. In this case, it's going to receive a marker color. So in other words, if you just wanted to assign some points a color, you could have those as attributes. You can come in. I'm not worried. No problem. All right. But we have to sit in total darkness. No, it's good. You're right. It's way easier to see. It's just that the light changed, the time changed the light. Okay. All right. So that's tag. Well, how am I using it here? I'm taking the quakes data and I'm feeding the state data into it, and I'm acquiring the name of the state. I'm acquiring the name and I'm giving it the label state in the new data set. So what does that mean? Well, if I run this again, now this will be this feature collection. This is all of the earthquakes tagged. Oh, I didn't save it. There we go. So now this is all of the earthquakes, the 288 earthquakes. And if I look at the earthquakes, it's going to be hard to pull out an earthquake because there's lots of earthquakes all over the world. But they'll have this new attribute, state, properties. I guess they only show up in the ones that. So this earthquake happened in New Zealand, which there was no state next to New Zealand. In fact, they just had a big earthquake in Christchurch. What was it, a day or two ago? Yeah, and that place, I went to a conference there 5 years ago, and the conference was supposed to be in Christchurch, but it had to be moved because of an earthquake. And now they just had another earthquake. So that's crazy. So there's Mexico. We're getting a little bit closer. But anyway, the ones that actually intersect with the state will have the properties of that state. one says California. Let's see that. let's see if I'm just making sure I'm doing this right. So tag is date the point, and it's going to get the marker color and assign it out there. Huh. I'm gonna console.log this filtered to make sure that it's working. I thought this was working before I came to class, but something doesn't appear right. The idea here is that I'm going to get all of the earthquakes. I'm gonna use this to tag the earthquakes with the state, and then only return the California earthquakes. That's what I'm trying to do. So let me run this again. Now I should be just looking at the filtered data. Features 15. These should all be in California. California. Yep, so that is working. I don't really know why tag didn't get the state name. Maybe it's just not putting it out into the console. Okay, but it is working, because at this point we are getting here, and this one's definitely working. So what that's doing is saying, okay, take the tagged data and then filter it. Filter is another function. Filter was the function that I went over earlier, that basically filters them by some attribute. So here, you give it the list of points or any features. Actually, the filtered will run on points, lines, or polygons, as long as they're GeoJSON. So you filter them, and here we've given it the filter me. I don't know why. It looks like it didn't match anything. It'd be better to change it to something that did match, and then return a true. Oh, filter me. Oh, so this attribute is equal to true. We made it so that it said if the variable so we basically, in this line, we created a new column called state and populated it with the name of the state. And in this line, we're saying, okay, find only those that are in California. How to do that in ArcGIS? What's the equivalent tool in our toolbox that's kind of like filtered or filter? Yeah, it'd be an if condition. And there are a few ways to implement an if condition. You could just go select by attributes, right? And that would like highlight them. But this is a little more similar to the select tool. Any of y'all ever use the select tool in ArcGIS? That's under analysis tools, extract, select. So select allows you to have input features. It creates a new feature class and allows you to enter an expression like, this would be the equivalent if we said state equals California. So this would be the equivalent operation inside of ArcGIS to do this. So we filtered it, and we display just the filtered data. Now, we didn't display the filtered data, we just filtered it. What if we actually want to display the filtered data rather than the initial data? We could change this down here to filtered. Let's see if this does anything. This should just give us earthquakes in California. Yep. See, now we're only seeing the California earthquakes rather than all of the earthquakes, because we fed it the filtered instead of the tagged. Now, the tagged ones, the filtered ones were still tagged because we took the tagged data and applied them to the filtered data. So they chain together. First we tag them, then we filter them. So now they have the attributes, and then they've been filtered. All right. Finally, this last one just goes through and it takes the quantile of the average. And so our second breaks are, okay, so the second breaks are just NaN, NaN. What that means is we probably have very, very small values because we're asking for the 50th percentile, the 97th percentile, and the 100th percentile of the averaged earthquake values. And we're getting some crazy values. I wonder if we change this to, oh, that's probably still going to be not a number. I wonder why that is. Yeah. Anyway. Oh, okay, I know why this is. Because it's including the NaN values. So it's taking the NaN values all the way to 100, and it's lining all the NaN values up, and at the 50th percentile, 50% of the values below NaN are NaN, and 50% of the values above NaN are NaN. Okay, let's just say there's 100 values, and what it's saying, well, actually, there's only 52 values. There's 52 states. So when we say 50, it's going to the 26th state and finding out its value. It lines them up lowest to highest. Well, that's still not a number. So what we could do is actually filter. What I'm going to do here is filter the average values, the average state values. I'm going to filter them by the magnitude average. I wonder if I can, let's look at the help. I wonder if I can filter a value. They have to match a property value. It's more like I want to do an if-then, an if statement. I don't see that one. There's got to be a way to do that. Remove. Match a property value. That's the opposite of filter. Yeah. All right, I don't see that. Let's get rid of that for now. I was thinking there was a way that we could actually find we can actually get rid of the not a numbers. Oh, we can do that, I think. So there is a remove. I just saw that. It took me a second to get my brain to work. So we're going to go turf.remove, and we're going to say averaged, and we're going to have the magnitude average, and we're going to remove it if it's equal to NaN. I think that's how we'll have to do it, and we're going to call this state filter. And then we're going to assign this back to 3067 or 3367. Let's see what this does. So hopefully this will remove all those values from averaged where the magnitude average is equal to not a number. And then we'll get a much nicer range of values. Still didn't work.
know the code, what you want or not. You just put it at the same way you put the other features in the parentheses.
I'm sorry?
Inside the parentheses? Yeah, there.
Yeah.
It was oh yeah. I thought it was weird because it was only an a n. It was just, and this is what tells you what you want to filter, right?
Right.
And
Yeah.
it was just the same way the other things were. So
Yeah, I'm just having trouble. So I'm sure this works, but this is where this is where it's breaking. It's because it's not making the comparison, so it's not actually removing anything. It's not removing those values. They're still there. So it's still putting those values in there. And so I just have to find out how to give it NaN as a value, and then this would work. Right now it doesn't work. So maybe during the break I can figure that out. All right, so that's why this is producing all red values, because it either has an earthquake or it doesn't. And then this is symbolizing those by those values. All right. Okay, I think that's a good place to take a break. I'll leave that up for a second. So let's take like a 15-minute break, and then we'll practice a few more turf.js functions, and then we probably end a little early today so I can help some of the students on their projects down here. All right, so I'm going to take a little break, get a drink, and I'll be right back.